Now we're going to talk about alternate forms of the Pythagorean identity. So just remember from earlier, gosh, I forget which section it is. I think it's, well, we had sine squared t plus cosine squared t equals 1. And if you were to take this and divide everything by sine squared t, you get this one, 1 plus tangent squared t equals secant squared t. If you take the original and divide everything by cosine squared t, you get this equation, cosine squared t plus 1 equals cosecant squared t. So if cosecant t is 12 over 13, and t is in the fourth quadrant, find the values of the other 5 trigonometric functions. So cosine is going to be positive, sine is going to be positive. Not sine, secant, I totally misspoke, I apologize. So we know right off that secant t is going to be 13 over 12. Okay. We also know that, let's see what I can put together. We know that sine squared t plus cosine squared t equals 1. So that sine squared t plus 12 over 13 squared is 1. So sine squared t equals 1 minus 12 squared is 144, 13 squared is 169. So I believe that's going to be 25 over 169. And so since we're in this quadrant, sine of t is plus or minus 5/13. And because we're in this quadrant, the fourth quadrant, we're going to go with the negative. So we know that sine t is going to be negative 5/13. So I use the Pythagorean identity for that. And let's have some fun with this. We already got secant. We got sine. You know what might be fun? I mean, I know that we could do tangent is going to be sine over cosine, which that'd probably go actually pretty quick. But if we could use this instead, couldn't we? We could say that 1 plus tangent squared t equals secant squared t. So that tangent squared t is going to be secant squared t minus 1. By the way, if you're going to go on the calculus, this will be helpful for you. So that's going to be 13 over 12 squared minus 1. So 169 over 144 minus 144 over 144. That's just 1. So I'm going to get 25 over 144. So tangent of t would be plus or minus 5/12. And again, because the quadrant we're in is going to be the negative. So we know that tangent t is going to be negative 5/12. Now we could have done that the easier way is if we did sine over cosine. So sine was negative 5/13 over 12/13 would have been negative 5/12. And now we'll look at cotangent t is going to be just this reciprocal, so negative 12 over 5. Okay, and that's it. What else did we find? We found this one here. Oh, I didn't do cosecant yet, did I? So we're not done. Cosecant t. I could use a Pythagorean identity, but I'm just going to do the reciprocal of sine. So that's going to be negative 13 over 5. There we go. Okay. Notice we discussed in this chapter opening a function that repeats itself, repeats its values in regular intervals. So in the chapter, not the section. Regular intervals known as a periodic function. The trigonometric functions are periodic. For the 4 trig functions, sine, cosine, cosecant, and secant, a revolution of 1 circle or 2 pi will result in the same outputs for these functions. And for tangent, cotangent, only half a revolution result in the same output. So our period for those first 4 is 1 full circle. Our period for tangent, cotangent is just half a circle. So find the values of the 6 trig functions for this angle. Okay, well, we know that sine of t is going to be the y value, so negative square root of 3 over 2. That's because it's a unit circle, right? Yes, it is a unit circle. Cosine t is going to be the x value, so negative 1/2. Tangent t, it's going to be sine over cosine, so it's going to be negative square root of 3 over 2 over negative 1/2. It's negative square root of 3 over 2 times negative 2 over 1. So it's going to be the square root of 3. Cosecant t is a reciprocal of sine, so it's 1 over negative square root of 3 over 2, which is negative 2 over the square root of 3. And if we rationalize that denominator, we get negative 2 root 3 over 3. We've seen that before, haven't we? For secant t, that's going to be 1 over cosine, so 1 over negative 1/2, so negative 2. And finally, cotangent t is going to be 1 over tangent, so 1 over the square root of 3. And if we rationalize that, we have the square root of 3 over 3. That was fun. So if sine of t is negative square root of 3 over 2, and cosine is 1/2, find secant, cosecant, tangent, cotangent. So our secant t is going to be 1 over the cosine, so 1 over 1/2. That's going to be 2. For cosecant t, it's going to be 1 over sine, so negative square root of 3 over 2, or negative 2 over square root of 3, which, again, as we saw in the previous problem and one earlier, negative 2 root 3 over 3. If we rationalize the denominator, tangent t is going to be negative square root of 3 over 2 divided by 1/2. So negative square root of 3 over 2 times 2 over 1. So negative square root of 3. And cotangent t will be equal to just the reciprocal there, or we could say 1/2 over negative square root of 3 over 2. So 1/2 times negative 2 over the square root of 3, we multiply by the reciprocal. The 2's divide out, leaves us with negative 1 over the square root of 3, or negative square root of 3 over 3. So that's those 4 things. Sorry, this video's gotten a little bit long, but we'll stop it there.